So moving on, for the final lightning talk, we have Ayesha Kasturiarachchi. Ayesha is a data scientist by profession. She completed her bachelor's in statistics from the University of Colombo and master's in data science from the University of Moratuwa. She is also a CIMA past finalist. Ayesha has more than 6 years of experience in research and data science disciplines with a touch of FMCG, pharmaceuticals, and telecommunication industries. She currently works at MAS Holdings as an expert data scientist driving digital excellence initiatives. So with great pleasure, I would now invite Ayesha Kasturiarachchi for the final lightning talk. She'll be speaking on the topic Wearing Data Science, Leveraging ML and AI in the Apparel Industry. Over to you.
Hi everyone, I'm sharing my screen. Hope that you can see it. Just let me know. So, is my screen visible?
Still we can't, okay, yeah, now we can see your screen, Ayesha.
So, hi everyone, good morning. And I firstly want to thank you for the opportunity. It's good to be with you all. So, moving into my topic, my session today evolves around an industry which is part and parcel of our day. So, the day-to-day lives, which is apparel industry. So, unlike any other industry, apparel industry is connected with us humans in our personal and professional lifestyle. So, not a day goes by without being connected to it. And let us see how data science could help solve some issues in the industry. Moving forward, first let's look at some key features that it differentiates from other industries. So as you can see, there are different key features, unique features that differentiates apparel industry from other industries, such as fit variability, size and fit, that it's fashion driven, labor intensive, seasonality are some of those key features. But in interest of time, I will be only speaking about three unique features of apparel industry, which are seasonality, personalization, and labor intensive. So moving into the first point, seasonal effect. So as you already know, to give an idea, so the clothes that we wear in winter are not as same as the clothes that we wear in summer. To give a more Sri Lankan approach, the clothes that we wear in Auradu is not as same as what we wear in Christmas. So you can see that there are different seasonalities that are connected to this apparel industry. If we take some other industries for an example, let's say biscuit industry, we know for a fact that in all the times there would be a seasonal demand. In stationery, there would be a seasonal demand when the school begins. But in those biscuit and stationery examples that I mentioned, there is only one seasonality that we can see. But in apparel industry, we can see many seasonalities that is coming from either weather patterns or festivals. So let's see how we can use data science to handle those seasonalities and to make necessary actions. So the main tool that we are using is forecasting. So we try to forecast the demand, the seasonal demand that we are getting, so that we can adjust our demand and in manufacturing processes. So the first point, so I have simply visualized how this happens in a very simple way so that we can understand. The first point is about data collection. So in terms of data, we need historical sales demand data. So we need to know what actually customers bought in the past with a time frame. And also we need supporting variables such as weather patterns, fashion trends, or holidays, promotional activities, which we think that will have an impact in sales demand for each seasonality. The next step that we are moving to is data pre-processing. So here it is mainly about smoothing the outliers and handling missing values. So unlike prediction use cases such as classification and regression, we can't really remove the missing values because the data is not independent. So we have to somehow handle missing values. So that is coming under data pre-processing. After that, we are moving to EDA, that is exploratory data analytics, to understand underlying dynamics of the demand, which leads to feature selection, where we can identify the impactful features that we think or we might see in exploratory data analytics that will have an impact on our season or our sales demand. Then moving to the next point, it's about model selection. So I would say that model selection highly depend on the data, whether the data have a clear seasonality or not. So to give some examples, we can use classical methods such as SARIMA, and regression models with time component, and move to some complex algorithms such as neural networks, and also uh, out, uh, uh, some models such as FB preferred. And after model selection, we do the normal model training and evaluation, and we generate forecasts. Now the question is, what are we going to do with these forecasts? So what we are going to do is we are adjusting the demand. We review the forecast and we think, okay, this is going to be our demand, and we plan ahead. We can plan the manufacturing process, we can plan the supply chain using those forecasts. So the demand should be regularly compared with actuals, and we have to make adjustments to forecast based on real-time information. Of course, there could be some market dynamics that we can't actually feed to a model. So in those cases, we would adjust the machine model generated forecast a little bit and say, okay, this is our future demand. So this entire process should be going as a continuous improvement, incorporating feedback, updating models, and leveraging advanced techniques in the future. So this is how we try to handle the seasonality using data science. So moving into the next feature, the next unique feature that I was going to speak about, it was about personalization. So when it comes to a cloth, the item, so there would be different preferences. Even for the same garment, there would be different preferences in terms of size, color, material. So we obviously, as a company, we can't handle all the preferences, all the requests that we are getting. So we need to strike a balance between the interest of maximum number of customers, of getting the maximum number of customers versus achieving business objectives. So let's see how we can solve personalization related issues using data science. So I'll simplify, and this is using NLP to collect product reviews data. So we start from product the data. So these would be text. So in terms of pre-processing, we will have to remove information, handle misspellings, remove stop words, and do text normalization. Then for the model building purposes, we have to assign sentiment labels, which are meant by annotation, and where we segment good and bad reviews, which leads to feature extraction. So we can have many methods such as bag of words and word embedding tools to extract features out of those pre-processed texts. Then we are moving forward to model training and evaluation. We can use start with small models such as naive Bayes or SVM, or move to complex models such as RNN or CNN. So this will, by using this specific model, we can generate sentiments or insights for new product reviews. So this feedback is sent to new product development to be more productive and cater as much as customer segments while achieving business goals. And moving to the final feature that I'm going to talk about, it is about labor. It is about being labor intensive. So this is mainly applicable to manufacturing. So this is highly labor intensive, where high number of employees at different experience levels are there. So there are around thousands of employees, thousands of sales orders, thousands of styles and related operations. So how are we going to create the optimal plan? to cater all the sales order line items and to make sure that all the deliveries are done on time. Of course, failing to plan is planning to fail. So we need to make sure that we do this planning properly even before starting manufacturing. So for this, this is the common approach that can be used. So we have to collect data first of all. So we need to know the employee's experience for each style and operations. So there could be some employees which are good at one style but not in another. So we should have all those information and frequency and time taken in the past. So as well as the quality that they have achieved in the past. Also, we need to have order details of sales orders, like what are the quantities that we have to produce in the coming 3-4 months, what are the delivery times, what are the status of material in-house. So those are some of the data points that we might need. So in terms of constraints and objective functions, so I'm moving towards an optimization algorithm here. So in terms of constraints, as an example, there shouldn't be any idle modules, and one person should only be at one module at a given time. And for objective function, we can have maximized utilization or minimize idle time. So in most of the cases, this optimization leads to a nonlinear problem. So at the end of the project, the result would be for each sales order, we might know how many modules should be allocated, who are the exact employees that should be allocated, and what are the exact days that we are going to do this manufacturing. So this is more or less a mathematical modeling problem that we are trying to handle. So to give in a nutshell, we have discussed about 3 key features: seasonality, personalized, and labor intensive. So I would like to talk about one other feature, which is short product life cycle. So in fashion industry, we already always have a very short life cycle, which leads to very short window to maximize our revenue. So this is having a short product life cycle is the center to all above factors. So we need to handle all above factors in a timely manner, and the need comes with the fact that there is a short product life cycle. So for an example, when we take the first example, the seasonalized, we have a short window to generate revenue, and if we even if the underestimation of forecast will lead to lost opportunity, and overestimation will lead to cost to the company because we have already manufactured overstock. And the personalization, we need to cater the right thing at the right time, and we have to take the necessary actions then and there. And the third point about being labor intensive. So in planning, we can't afford delays because we have a really short window. We can't say, okay, we can't manufacture it this week, let's manufacture it next week. No, that is not an answer, but we have to be on time. So which is why I would say that short product cycle is the key unique feature which creates the need, or creates the urge to have this machine learning or data science algorithm in apparel industry. So moving to the end, incorporating data science might not be as beautiful as it looks from the outside. Of course, there are limitations restricting from using AI and ML. So to discuss very few in a summary. So we have a manual data capturing processes, especially in factories where it is highly labor intensive to how to measure the time taken to do a certain operation. So there's a huge gap on how to enter those data into systems. Of course, even if they enter the data, it would be something like an Excel sheet. So how to digitalize those data to a system, that is the first question that we have. And moving to the next point. So unlike banking or telecommunication industries, manufacturing industry doesn't force to have data in a proper system. So developing data storage systems would be a different whole new process for manufacturing organizations, unlike banking or telecommunication. So it is a limitation that we have faced. And the third one is about data drift because of the fashion-driven dynamics. So there are instances that we try to build machine learning models using some data, let's say up to 2023 May. but it will be less applicable if we go, when we go to, let's say, next year, because of the data drift, because of the fashion trends might have changed by then. So that is one limitation. Also, the next one is about sentiment driven industry. So this is the industry itself. The demand is how people think, act, and behave. So it's a bit hard to convert it into data. So that is one limitation we are facing. And finally, the cost and expertise. I think for most industries, this is one of the main limitations. So which is main limitations for apparel industry as well. So those are the limitations that we generally face when trying to adapt data science or machine learning technologies into apparel industry. So to give a final thought, apparel industry is a colorful industry with different dynamics, and data science can certainly help make it better. So we are constantly striving to achieve that. So with that final thought, I want to thank you for the opportunity. And Soumya, over to you.
Thank you very much, Ayesha, for enlightening us with that very informative speech.